In this video, we are going to discuss about the NPN operation and the current equations and early effect. First, we can see about the bipolar junction transistors. So here, in bipolar junction transistor, it consists of two diodes, and this operation of this transistor depends on both the majority as well as minority carriers, since this has the back-to-back connection of two diodes. And here the voltage between the two terminals will control the current through the third terminal. So this bipolar junction transistor is completely a current control device, and it can be used as amplifier and a logic switches. It has the three terminals. One is collector, base and emitter. Under this only we are going to study about the types of the BJT, that is PNP and NPN transistor. So here you can see the transistor construction. The transistor is consist of 3-layer semiconductor device, which is consisting of 2 N and 1 P type layers of material. And in the case of the PNP transistor, it consists of 2 P and 1 N type layers of the material. The term bipolar is nothing but the holes and the electrons will participate in the injection process into the oppositely polarized material. That is nothing but, since it is a bipolar, it is consists of the diodes which is connected back to back, that is in opposite direction. A single PN junction has two different types of bias. One is forward bias and another one is reverse biased. So the positions of the terminal and the symbols of the BJT is, if the base is located at the middle and more thin from the level of the collector and the emitter, then it is said to be common base configuration. And the emitter and the collector terminals are made up of the same type of the semiconductor material, while the base is connected with the other type of the material. So you can see the positions of the PNP and NPN. So in the first diagram you can see the NPN transistor, which is connected as collector, base and emitter, and the current is flowing from the emitter to the base. In the second figure you can see the NPN transistor, where the current is flowing from the base to the emitter. So this arrow is always drawn from the emitter, so the arrow points towards the N type. In this PNP, the emitter to base, the arrow will be indicated, and in the NPN, from base to emitter it is indicated. So IC is nothing but the collector current, IB is the base current, IE is the emitter current. Transistor operation. So let us see the transistor operation of the NPN transistor, and this operation is exactly same if their holes played by the electrons and holes are interchanged. So here you can see one of the diode is forward biased and one is reverse biased. When both the biasing potential has been applied to the PNP transistor, and the resulting majority minority carriers will flow as indicated. The majority carriers, that is positive, will diffuse across the forward biased PN junction into the N-type material. When a small number of carriers are passed to the N-type material to the base material, then there occurs the change in the variations, that is from P to N-type material. The larger number of the electron carriers will exactly diffuse from across the reverse bias junction. So this is completely reverse biased. And the majority carriers can flow across the reverse bias junction, which will appear as the minority carriers in the case of the N-type material. So when you apply the KCL to this transistor, the emitter current will be always equal to the collector plus base current, because this emitter current will be having 100%, and when it comes to the collector, when it comes from collector, some of the electrons will be diffused or deposited in the base, that is mainly 2% of the electrons will be diffused in the base. So 98% only will comes from the base material. And the current equations, you can see the NPN structure here. So when with the voltage VBE and VCE, You can see the forward and the reversed junction, that is base to emitter junction is forward biased and base to collector junction is reverse biased. And you know the current equation, nothing but E is equal to I naught into E power Vn by Vt minus 1. Due to the large differences in this doping concentration, some of the electrons can be injected in the base region, which results in the emitter current. And also, number of electrons injected in the collector regions is directly proportional to the electrons injected in the base from the emitter region. So when you see the relationship between the current, base current and the collector current, IC equal to beta into IB, and when applying KCL, IE is equal to IC plus IB, you know that IC is equal to beta into IB, so you can apply the value here. So IE is equal to 1 plus beta into IB, and the fraction is also called as alpha. So here it is denoted in the terms of the values, beta value equal to 100 and alpha equal to 0.09, and always we know the current will be flowing from the emitter side. Early effect. So here whenever we apply the voltage, the base emitter and the base collector junction will be changed. With the change, how much of changes is obtained due to the change in the voltage, the depletion width will also vary, and this causes the collector current to vary with the collector emitter voltage. So this variation is shown in the figure, and the variation, the gradient of the minority carrier density therefore changes in the increased collector current, which we called as Ailey effect. Ailey effect is nothing but the increase in the collector current with the increasing in the collector emitter voltage. So this will be increased or decreased based on the changes in the voltages, and you can see the variation as DIC equal to DVC equal to minus DIC divided by DVBC. And the collector current, if there is an increase in the collector current, then there will be increase in the collector emitter voltage due to this Ailey voltage. So since there is an gradual increase, it can be determined as, variation can be determined as DIC divided by DVC equal to IC by VA. And these are the equations of the Ailey voltage equation. And in addition to this, we are seeing the variation in the base emitter voltage, which will be changed in the ideality factor of the collector current, and this variation can be denoted in the terms of N. And also the current equation, you can substitute the value in the current equation. So where IC is the collector saturation current. Thank you.